video series is intended to cover the Algebra 1 of Beka textbook. We will cover each lesson and go through them step by step and give you chances to practice this on your own, as well as I will tell you the classwork that is assigned for each one. This video series is meant as the lessons for the textbook, not as a supplement to them.
So here's our textbook, as I just mentioned before. The one I'm working off of, I'm teaching out of the second edition of the textbook. So if you don't have this edition, the lessons may be a little bit different, but they should cover the same basic information. So today we'll be doing lesson 1.1. As you can see, there are 15 units in this book, and we will try to cover each and every one of them to the best of our abilities. So, from arithmetic to algebra. If you're familiar with the principles of arithmetic, you should have no difficulty with algebra. Algebra, indeed, is simply an extension of arithmetic. In algebra, you add, subtract, multiply, and divide integers or numbers and fractions using the signs plus, minus, multiply, and divide, indicating these operations. You factor products, raise numbers, 2 powers, and find their roots, just as you do in arithmetic. Algebra, to be sure, makes a wider application of the principles learned in arithmetic. It gives an extended meaning to these signs and introduces new symbols and topics, but you will pass so naturally from familiar to new ideas that your horizons will be enlarged without great effort on your part. One of the chief distinctions between arithmetic and algebra is the extensive use in algebra of letters to represent numbers. Even arithmetic, where the 10 digits, 1, 2, 3, 4, 5, 6, 7, 8, and 9, and also 0, are generally used, numbers are sometimes represented by letters. Thus, X in Roman numerals represents 10, C 100, M 1000, etc., etc., etc. The difference is that in algebra, X, C, and M are under different conditions, and they may represent different values. Thus, in X equals 6 plus 3, X represents 9, while in X equals 8 minus 4, X represents 4. So our numbers are not going to always equal something that's set. We're going to have to figure out, and through working our problems, find out what our numbers and letters mean in the context of the problems that we're working on. In arithmetic, letters are also used in formulas. Thus, the formula for the area of a triangle is A equals B times H. Means that the number of square units in the area equals the product of the number of units in the base by the number of units in the altitude. If B represents the number 5 and H the number 4, then A represents the number 20. So in this unit, Unit 1, we're going to talk about how to use those letters to simplify the statements and solution of problems and to shorten the workload. So we're going to take our really big problems and we're going to make them really small. So if you want to represent the value of several coins, you may use the letter Q to represent quarters, D for dimes, and C for cents. If the number of coins consists of 5 quarters, 4 dimes, and 3 cents, you may write it 5Q plus 4D plus 3C. How you write the sum of 2 quarters, 3 dimes, or how could you write the sum of 2 quarters, 3 dimes, and 4 cents? You could write it 2 quarters plus 3 dimes plus 4 cents. So, let's go over some of the problems in exercise 1.1. So exercise 1.1 question 1 says, if h is equal to 100 and t equals 10, what is the value of h plus t? So we want to know h plus t and what it equals. Well, if we know that h is equal to 100, we can plug in 100, and we know that t is equal to 10, so plus 10. Now it's a simple matter of adding it up. 100 plus 10 is 110. And then we have our answer. Not quite as difficult as a lot of people think it's going to be. Now about question 3. If P equals 16 ounces and O equals 1 ounce, how many ounces are represented by P minus O? Well, again, let's set it up the same way. P minus O equals what? Well, P equals 16. So 16 minus O equals 1. Equals 16 minus 1 is 15. So exercise 1.1 is fairly simple and quite easy in that way. The first 4 problems in the textbook are ones simply exactly like the 2 we just did. Now, in algebra, multiplication may be indicated by a raised dot or without any sign. So in this instance, we would show that A times B and A times B. Both of these are the same as saying A times B. It all is the same way, and we can replace numbers and it would all mean the same operations. In the same way that 3A times B, 3AB, and 3 times A times B, where 3 multiplied by A multiplied by B, whichever term you choose to use. So, questions 5 and 6 are basically asking you to use this information to answer those questions. Now, division can also be indicated using 2 different ways. One of these that you're going to already be quite familiar with, actually. You just don't realize that you're familiar with it. So, A divided by B and A over B both mean A over B. Now, this one, we call it a fraction. Like I said, I knew you would already be familiar with that term. So, it still means to divide something though. So if I take 3A over B, this means to take it and go 3 times A divide by B. And then you would simply plug in your numbers and work it. In this way, you'll be able, later on we'll show you and you'll learn how to do it so that you can divide it and multiply it all, leaving it in a fraction form. So that was the end of today's lesson. Like I said, today's lesson was very easy. Not that difficult and complicated to get through. You only have a couple of questions, and a lot of it is just reusing and relearning what you already know, as well as trying to apply a little bit of a new concept and calling it something slightly different. So we're still working with our numbers, but we're adding in letters. We're still working with the same signs, but we're adding in new signs that mean the same thing. We're still working with fractions, but we're working with them in a different way, and that's about it. So, our next lesson is going to be about abbreviating statements about numbers. See you then.